On lesson 9, we will study the product rule. That means what is the derivative of the product of two functions? The derivative of the sum of two functions is the derivative of the first plus the derivative of the second. But now we are going to see that the derivative of the product of two functions, the derivative respect to the x of the product of two functions, the derivative respect to the x of f of x multiplied by g of x, this is not f prime of x multiplied by g prime of x. No. How to do this, how to apply the product rule? The product rule says that the derivative of the product of two functions multiplied by g of x is the derivative of the first, f of x, by the second, g of x, plus the first by the derivative of the second, g of x. We can write this like f prime of x gx plus f of x g prime of x. And this is the product rule, and the quotient rule say that the derivative respect to the x of f of x divided by g of x, of course g of x is not zero at any point, otherwise you cannot find the derivative, is the derivative of the first by the second minus the first by the derivative of the second divide by g of x squared. And this is the two rules that we are going to apply, the product rule and the quotient rule. Let's go to do problems now. So these are the 12 problems that we are going to do. Let's go to start solving this problem. So we apply the product rule. So we have here the product of two functions, x cubed and cosine of x. What is the derivative of this product? The derivative of the first, 3x squared, by the second, cosine of x, plus the first, x cubed, multiplied by the derivative of the second. The derivative of cosine of x is minus sine of x. So if you can take common factor x squared, and you will have this expression. Let's go to the next problem. Use the product rule for this function. So the function f of x is made of two functions. This is, we can say f of x, the first and the second. And there is a product between the first and the second. So the derivative is the derivative of the first, 2x, by the second, x squared minus 4x, plus this first multiplied by the derivative of the second. The derivative of x squared is 2x, the derivative of 4x is 4. Is 4. I made a mistake here, is 4. Is 4. Okay, now it's correct. And you do the algebra and you put it nicely, okay? Multiply this, etc., etc. Let's go to the next one. Use the product rule the quotient rule to find the derivative of this function. The derivative, so we do the derivative of the first multiplied by the second minus the first multiplied by the derivative of the second divided by the denominator, g of x, the denominator squared. So let's go to do it. What is the derivative of the first? 1. What is g of x? The denominator, x squared plus 1. Minus f of x. What is f of x? X. What is the derivative of g of x? Is 2x. Divide by g of x squared plus 1 squared. So this will be equal x squared plus 1 minus 2 times x squared divided by x squared plus 1 squared. And this will be x squared minus 2x squared is minus 1x squared plus 1 divided by x squared plus 1 squared. And this is the result. You can go a little bit, I leave you to go a little bit further to try to simplify this expression. Let's go again, use the quotient rule to find the derivative. So, is the derivative of the numerator. What is the derivative of the numerator? Cosine of x. Multiplied by the denominator, x squared, minus the derivative minus the numerator, sine of x, multiplied by the derivative of the denominator, 2x, divided by x squared. So this is f prime of x. This is, without taking the limits, it would be difficult to take the limits definition and to find this result. Of course, we can do it, no, but it's long. So this is the derivative. You can maybe simplify this expression. And let's go to do this. Find the equation of the tangent line at the point minus 1, 4. Well, we know how to do this. The problem here is to find the derivative of f of x. The derivative of f of x is the derivative of the function x cubed plus 4x minus 1. Of course that we can multiply and do the derivative. We can multiply here using the distributive property and obtain a long polynomial, and we make the derivative. But the thing is that it's faster to do it in this way. What is the derivative of the first? Is the derivative of this product is the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. Okay, let's go to do it. The derivative of the first, 3x squared plus 4, multiplied by the second, x minus 2, plus the first, x cubed plus 4x minus 1, multiplied by the derivative of the second, 1. The derivative of x is 1. The derivative of minus 2 is 0. Oh, so this is the result. And now you can multiply and work a little bit this problem and find what we have done many times, that is find the tangent line. This is the derivative. This is the derivative respect to the x of f of x. What is the slope at the point x equal 1? Well, the slope at the point x equal 1 is 3 plus 4 multiply 1 minus 2 minus 1 plus 1 plus 4, 5 minus 1, 4 multiply. So the derivative of x equal 1, the derivative of x equal 1 is 3 plus 4 is 7 minus 7 plus 4. And minus 7 plus 4 is minus 3. So the slope at the point x equal 1 is minus 3. So the problem is asking you, use a graphing utility to graph the function and the tangent line in the same. Well, if you want to find the tangent line, will be y equal y0. Y0 is minus 4. Minus 4 plus m is minus 3 multiplied by x minus 1. And this is the equation of the tangent line. If you try to do it using the distributive property, you will find the same result, but it will be longer. Let's go to the next problem. Find the equation of the tangent line to the graph x minus 1, x plus 1 at the point. Okay, find the equation of the tangent line. So we need to find the slope. And we need to find the slope at x equal 2. So the problem is, what is the slope of this function at x equal 2? So we make the derivative. The derivative respect to the x of x minus 1 divided by x plus 1 is the derivative of the numerator, 1, because the derivative of x is 1, the derivative of minus 1 is 0, multiplied by the denominator, x plus 1, minus the numerator, x minus 1, multiplied by the numerator. The numerator multiplied by the derivative of the denominator. The derivative of the denominator is the derivative of x is 1, the derivative of 1 is 0, so it's 1. Divide by the denominator squared, the denominator is x plus 1 squared. So 1x plus 1 minus x, cancel with this x, minus 1 is plus 1, so it will appear a 2 in the numerator divided by x plus 1 squared. If we evaluate it at the point x equal 2, we find the slope. If x equal to 2 plus 1 will be 3, 3 squared will be 9, so the slope would be 2, 9. So, and the problem is say, find the equation of the tangent line. So the tangent line will be y equal y0 plus the slope f prime of x0 multiplied by x minus x0. So the equation will be y, because the point P is the point 2, 1/3. So the equation will be y equal y0. Y0 is this point. Y0, x0 is the point P. Is 1/3 plus the slope 2, 9 multiplied by x minus x0. x0 is 2. If you make a little bit of algebra, will be 1/3 plus 2, 9 of x minus 4, 9. And if you do a little bit more of algebra, will be 1/3. If I multiply by 3, will be 3, 9 plus 2, 9 of x, 2, 9 of x minus 4, 9. So it will be y of x. The tangent line will be 2, 9 of x. Now 3, 9 minus 4, 9 is 1, 9. 1, 9, so this is the equation of the rectilinear line that pass through the point 2,13 and touch in one point the curve. This point, in this point, it kisses the curve tangentially. Now this problem, say problem 7, find the derivative without doing the quotient rule. Okay, we do the power rule. So we write f of x equal 10 divided by 3, and instead of 1 divided by x minus x divided by 3, we write x minus 3. And now will be minus 3 multiplied by 10 divided by 3 by x minus 3 minus 1, minus 4. So it will be the 3 will cancel, it will be minus 10, x minus 4, or in other words, the derivative. So let me write correctly. This is f of x, and this is equal f prime of x, the derivative. And f prime of x can be written like minus 10 divided by x4. And that's all. Now we do problem 8 that say find the derivative of this function, x squared tangent of x. So the derivative f prime of x is the derivative of the first function, 2x, multiplied by the second, tangent of x, plus the derivative plus the first multiplied by the derivative of the second. The derivative of tangent of x is secant square of x. Secant square of x. Why? Because tangent of x is sine of x divided by cosine of x. So I need to apply the quotient rule. What is the derivative of tangent of x? Remember that the derivative respect to the x of sine of x is cosine of x, and the derivative respect to the x of cosine of x is minus sine of x. Now let's go to apply the quotient rule to find the derivative of tangent of x. The derivative respect to the x of tangent of x is the derivative of the numerator, cosine of x, multiplied by the denominator, cosine of x, minus the numerator, sine of x, multiplied by the derivative of the denominator. The derivative of cosine of x is minus sine of x. Divide by the denominator square. Cosine of x is square. But you see here that in the numerator will appear cosine square of x plus sine square of x. Because minus minus, minus minus is plus. Divide by cosine of square of x. So what is cosine square of x plus sine square of x is 1. 1 divided by cosine square of x. And what is 1 divided by cosine of x? 1 divided by cosine of x is secant of x. But here it says 1 divided by cosine of x by cosine square of x. So it's secant square of x. So the derivative is x squared secant square of x, and this is the final solution. Okay, now let's go to do problem 9. It says like this. Find the derivative of the trigonometric function secant x divided by x. Remember that secant x is 1 divided by cosine of x. And what is the derivative respect to the x of secant x? The derivative respect to the x is the derivative of 1 divided by cosine of x. And what is the derivative of applying the quotient rule to this function? Is the derivative of the numerator, 0, by the denominator, minus the derivative of the denominator. The derivative of cosine of x is minus sine of x. Minus sine of x, it would be a positive sign, multiplied by the numerator divided by the denominator square. So this will be sine of x divided by cosine of x multiplied by 1 divided by cosine of x. What is sine divided by cosine is tangent of x. Tan x, and what is 1 divided by cosine of x? Secant x. So I have one equation that says that the derivative respect to the x of secant x is tangent secant, or secant tangent. Okay, you may remember. So now we have to do the derivative of this function of secant of x divided by x, but we already know this information that the derivative of secant x is tangent x secant x. So let's go to do it. The derivative respect to the x of secant x divided by x is the derivative of the numerator, tan x, secant x, by the denominator, x, minus the numerator multiplied by the derivative of the denominator, which is 1, divided by the denominator square, x squared. What we will have here? We will have here secant x that multiply x tangent x minus 1 divided by x squared. And the problem is solved. Now problem 10 say find the second derivative. So to find the second derivative, we need to find first the first derivative. And again, we differentiate the first derivative and we'll obtain the second derivative. So what will be f prime of x? F prime of x will be 3/2 multiplied by 4, x. 3/2 minus 1 is 3/2 minus 1, which is 2/2. Between is 2 divided by 2, it will be 1/2. So 3/2 minus 1 minus 2 divided by 2 is 1/2. So I found the derivative. 4 divided by 2 is 2, 6x 1/2. So this is f prime of x. And what is f second of x? Well, we make the derivative again. So it will be 1/2, 6x, 1/2 minus 1 is minus 1/2. So the derivative will be 6 divided by 2 is 3x minus 1/2, or 3 divided by x 1/2, or 3 divided by square root of x. And this is the solution. Now we practice again with the same problem with another function. The function is x divided by x minus 1, that is not defined at x equal 1, is not defined the function. But we are going to find the derivative at any point different than x equal 1. What is the derivative? It's the derivative of the numerator, 1, multiplied by the denominator, x minus 1, minus x multiplied by the derivative of the denominator. The derivative of the denominator, the derivative of x is 1, and the derivative of 1 is 0 because it's a constant function. Divide by x minus 1 square. Now we solve in the numerator, and we have the first derivative of the function is 1x minus 1 minus x. 1x minus x is 0. So in the numerator will appear minus 1 divided by x minus 1 squared, or minus x minus 1 minus 2. Now let's go to do the second derivative. The second derivative, applying the power rule, will be minus 2 multiplied by minus 1. This would be a plus sign. X minus 2 minus 1 minus 3. Or in other words, 2 multiplied by x minus 1 minus 3. Or in other words, 2 divided by x minus 1 cubed. And that's all. Now this problem says verify that the function y equal 1 divided by x, for x different than 0 and bigger than 0, satisfy the differential equation. The differential equation is an equation where it appears the derivative. Here is the first derivative, and here is the second derivative. An equation that appears the derivative of the function is named as a differential equation. And the challenge is, if x cubed, you multiply by the second derivative, and you add 2x squared, the first derivative. Who is y of x? This is the challenge of a differential equation, to find y of x. The problem says that y of x is 1 divided by x. So let's go to check if this is a solution of the differential equation. Y equal 1 divided by x is simple x minus 1. And y prime of f prime of x, or the derivative respect to the x of f of x, everything is the same, is minus 1, x minus 2. Perfect. And y second, I will need information of y second to plug in here y prime and y second and to sum to see if this is 0. Y second will be the derivative of y prime. it will be minus 2 multiplied by minus 1, x minus 2 minus 1 is minus 3. So it will be 2 times x minus 3, or in other words, 2 times x divided by q, and here it will be minus 1 divided by x squared. So let's go to plugging into the differential equation. The differential equation says x cubed multiplied by y second plus 2x squared multiplied by y prime equals 0. So let's go to plugging x cubed. Who is y second? If y is 1 divided by x, y second we find that is 2 divided by x cubed. The second derivative is 2 divided by x cubed and is positive, plus 2 times x squared. Now y prime should be negative, otherwise I will never find 0. And y prime happens to be minus 1 divided by x squared. Now if I make the sum, this x cubed will cancel with this x cubed and will be a 2. And this x squared will cancel with this square and it will be a negative 2. So this will be 2 minus 2. Is 2 minus 2 0? Yes, 0. So the equation is satisfied because the equation that says that to satisfy should be 0. And the problem is solved.